today we're still using that law of sines from yesterday. But you'll notice every problem we worked yesterday had something in common. I gave you two angles and one side. But I want to look at what happens if you are given more sides than angles. Okay, we can still use the law of sines, but if we're only given one angle, it turns out that there might be more than one triangle that exists. And so we have to be able to find all of those triangles. Now, if you are following in the book, they give you all kinds of rules of when there's only one triangle that works, and when there's going to be two triangles that work, and when it won't work at all, and we won't get a solution. But personally, I think it's more confusing to try to memorize a whole set of rules than it is to just work the problem and see if we get an answer or not. So that's what we're going to do. My strategy is just going to be to work it out and then see if our answers work. Now, to check if our answer works, we're just going to remember a few things. Remember, sine has to be between 0 and 1. So if you get like sine theta equals 5, does that triangle exist? No. All the angles have to add up to 180 degrees. So if you add them up and it's more than 180, that doesn't work. And then the second one is something I mentioned yesterday in checking our answers. When you do these problems, your smallest angle always has to be across from the smallest side. Biggest angle has to be opposite the biggest side. And that will be probably the thing we use most often to verify if we have one or two triangles that solve our problem. So typically when we don't have any solutions, it'll be because of the first one. We'll get sine to equal something bigger than 1. And even if you try to do it on your calculator, it's going to tell you domain error, so we'll say there is no triangle. Typically the thing that would make it only one triangle instead of two is we'll solve it and we'll get that the biggest angle is across from the smallest side, and we know that's not possible. So that's going to be what we look at here. So we're just going to start out solving them like we did yesterday. Okay, we have triangle ABC. I told you could draw a picture. It does not have to be to scale at all. We're just trying to organize our information. So side A, that's across from angle A, is 17.9. Side C across from angle C is 13.2. And angle C, 75 degrees, 30 minutes. All right, can we easily just find an angle on this one like we could yesterday? No. In order for that to work, we had to know two of the angles, and then we could subtract from 180. Since we don't, we have to have a different strategy for solving this. So we're actually just going to start with the law of sines. What angle and side do I have all the information for? C. So I have to use C over sine C. Okay, could I do B over sine B right now? No, because I don't know angle B and I don't know side B. So I would have to do A over sine A to start. So side C is 13.2 divided by the sine, 75 degrees, 30 minutes, equals side A, 17.9, over the sine of angle A, which we don't know. Okay, so cross multiply. And when I divide by 13.2, this is my calculator. 17.9. you guys get? Sine A equals 1.3129. What happens if you do sine inverse now? You have to be in degree mode. There's an error. Why did we get an error? It's more than 1. We know sine can't equal something bigger than 1. So this one is no solution. It tells me no triangle exists. Is that okay? Let's look at the next. Solve triangle ABC. If A is 61.4 degrees, side A is 35.5 centimeters, and side B is 39.2 centimeters. Let's just draw a picture. A is 61.4, side A 35.5, side B is 39.2. So which information do we have to use if we're setting up the law of sines? We have both angle and side for A. And the only other information we have is for B, so we'll have to do B over sine B. Right, so side A, 35.5, divided by the sine of 61.4 degrees equals 39.2 over sine of B. Cross multiply. And we have to divide by the 35.5. So are we going to get an answer this time? We solve for sine, we get 0.96949, so it has to be something between 0 and 1, so we will find an answer this time. So here's the thing to think about. If I want to find an angle, we have to do sine inverse, right? It's like those equations we were solving on our test. When is sine positive? So when I do sine inverse, I actually will have 2 angles. Okay, if we do sine inverse, that's going to give me my reference angle. And so I get 75.8 degrees. So we have to talk about the triangle in quadrant 1 and the triangle in quadrant 2. So in quadrant 1, your reference angle is your angle. So that was B would equal 75.8 degrees. How would I find that in quadrant 2? And that gives me the only information I have so far In comparing sides A and B, side B is bigger, so angle B has to be bigger than angle A. Are both of these bigger than angle A?
Yeah.
So far it looks like they both work. Now if I know both angles A and B, we could find angle C in each of these triangles.
You just have to take 180 minus.
So 180 for the first one, minus 61.4, minus the 75.8. And then the second triangle, same thing, but instead of subtracting 75.8, you're subtracting
4.2 and you get 14.1.
What other information do we have to find?
Yeah, so find the length of C.
Okay. So to find that, we have to do the law of sines. So now this is like yesterday. If you have two angles and you're looking for that side. So I have to do C over sine C. And you could use A or B. I'm just going to go with A. A over sine A. So C over the sine of 42.8 degrees equals side A was
35.5.
divided by the sine, angle A was
61.4.
so just like yesterday, all you have to do is multiply over the sine of 42.8. You get 27.570.
And then don't you have to do it for the 104.2 as well?
So in the second triangle, we're still doing the same thing. Side C divided by sine, but this time angle C is 14.4 degrees. Equals side A, 35.5 over the sine of 61.4 degrees. So all you do is multiply over the sine of 14.4. What do you get for side C? Let's do a quick check to verify. Is in both of these triangles, would the biggest angle be across from the biggest side and the smallest angle across from the smallest side? So if I did this one, 27.5 would be my smallest side and C is my smallest angle. 39.5 is the biggest and B is my biggest angle. Second triangle, B is my biggest angle and biggest side. C is the smallest angle and the smallest side. So in this case, we have two possible solutions. Two different triangles would work for that original information. So we've seen a case where we didn't get any answers. We've seen a case where we get two answers. Is that okay so far? Just going to keep working on it. So solve triangle ABC. Angle B is 68.7 degrees. Side B, 25.4 inches. Side A is 19.6 inches. So what would I start with? B over sine B equals A over sine A, since I gave you side A. So side B, 25.4, divided by the sine of 68.7 degrees, equals 19.6, divided by the sine of A. So first of all, is this possible? Yes, so we will get triangles. We have to find both quadrants 1 and 2 because sine is positive in both of those. Reference angle, so if we do sine inverse, we get 45.96, let's just round that to 46 degrees. So let's consider our two triangles. So in triangle 1, in quadrant 1, your reference angle is your angle. In quadrant 2, you have to do 180 minus that.
134.
Okay, you might notice a problem right now. Does anyone catch it? You can look, couple things. Which side is bigger, A or B? B is the bigger side, so that means B has to be the bigger angle.
And it's not.
And so 134 is bigger than that, so it wouldn't be possible.
And then additionally,
If-
68 added to the 134 gets you 180.
Yes.
And you don't even have your third angle.
Right. So if we went ahead and didn't catch it there and tried to find the third angle, so you do 180 minus 46 minus 68.7. That one is 65.3 degrees. Over here though, if you do 180 minus 134 minus 68.7, you get negative 22.7. In a triangle, can you have a negative angle? No. So whether you pay attention to the sides or you realize we got a negative angle and we need a positive, we can stop right there and say, okay, that second triangle doesn't exist. So I'm only going to have one possible triangle here. So let's finish it. We had sides A and B, so all we need is side C. So originally I had all the information for B, so I'm going to do C over sine C equals B over sine B. You could use A. We might have a little more rounding error since we found angle A ourselves. But as long as you showed your work, that's okay. So we'd have C over sine of 65.3 equals side B, which was 25.4 divided by the sine of 68.7 degrees. So we get side C to be 24.8 inches. So this time, we only had one triangle. So if we're only given one of the angles in the problem, we might have 0, 1, or 2 possible answers. Is that one okay? Want to keep practicing? Let me give you guys one. See if you can figure it out. See how far you get. for sine A, what'd you get sine A to equal?
2, 3, 2, 7, 6.
Got 2.318.
Yeah, I rounded up.
But either way, we see this is bigger than 1, so we know right now there's no solution. There is no triangle where this feature. Alright. Let's try another one. Did you guys get sine B equals 0.89787? So we know there is a triangle. You did your inverse, you get 63.9 degrees. So in quadrant 1, that would be angle B. And quadrant 2, 180 minus 63.9, 116.1. So angle C, 180 minus 63.9 minus 55.3.
60.8. And then in triangle 2, that would be 8.6.
So far, does everything work out?
Yes.
Okay, no negative angles, so we're good. So then side C, so we could do C over sine C equals A over sine A. So in the first triangle, it would be C over the sine of 60.8 equals 22.8 over the sine of 55.3. And get 24.2 feet. And in the second one, all it changes,
4.15 feet.
that angle C is different, so if you change that to an 8.6 and solve, you get 4.1 feet, depending on, I mean, it's like 4.146, so you could say 4.15 also.
Okay.
So just a quick check, we see our biggest angle is angle B. So side B has to be the biggest side, which it was. Angle A was the smallest, so side A had to be the smallest, and it was for the first triangle. Second triangle, angle B was the biggest, so side B had to be the biggest, and it was. Angle C was the smallest, so side C had to be the smallest, and it was. So both of these do work out. Is that good? Do we need another one? No? Think you've got it? So, your assignment, 1, 7 through 27, every other odd, and 37. And I will make this due on Tuesday. We'll give you guys 5.